Hey everybody, it's Mr. Carr again. Today we're going to be starting off with 5-7, and it's going to be 5-7 day one here, looking at roots and zeros. So it's a little bit more of our solving stuff, but we're also going to be dealing with our complex roots. So that's what we're looking at here. We want to solve x to the third minus 27 equals 0. In order to do that, then we're going to, as I said, state the number and types of roots as well. So the degree, as we said before, the degree of the polynomial is the total number of solutions, real and complex. We've always talked about it as being the highest exponent, and that's still technically true. But all the possible solutions, even real and complex, add up how many you have, and that's also going to be your degree. Complex roots, don't forget, those are always going to be in conjugate pairs. So how I'm going to do this is I'm going to start with factoring. X cubed minus 27 is 2 perfect cubes. So remember from before, that follows the pattern. It's a minus b, and then a squared plus ab plus b squared. Okay, so that means if I do that here, x is going to be a, and then, so like x cubed minus 27, that's the same as x cubed minus 3 cubed. So that means I've got a and b like that. So now I can plug those into their positions in my formula up here. So we got x minus 3, and then x squared plus 3x plus 9. Okay, and that's equal to 0. So from here, I can split this off and find one of my solutions. If this times this equals 0, then x minus 3 has to equal 0. So x equals 3. Here's my real solution right here. For the other part, x squared plus 3x plus 9 equals 0. Now I need to solve it with probably quadratic formula, but you can technically do completing the square if you wanted to. So I'm going to do quadratic formula now. Now I have a quadratic, but we should get complex numbers. I don't think we're going to get real ones. So let's try this out. So x equals negative, negative b, so negative 3, plus or minus the square root of 3 squared, minus 4 times a times c, all over 2 times a. Okay, put that our quadratic theory, quadratic formula, negative 3 plus or minus, that's going to be a 9 minus 36, all over 2. So that's negative 3 plus or minus the square root of negative 27 over 2. Okay, so when I simplified this one right here, okay, so I've got the square of negative 27. That means I do have an I in my answer. Okay, so we got, just check real fast. There. Okay. Sorry about that. Okay. Okay, so then we're going to break down the square of negative 27. Remember, that's the same as taking negative 1 times 27. And then 27 is 9 times 3, and then 9 is a perfect square. So that means this is going to turn into negative 3 plus or minus. This will turn into a 3. This will turn into an I. And then I still have the square root of 3 inside the radical. And that's all over 2. So I actually have 3 roots. I have 1 real and then 2 complex. Because my 2 complex ones are going to be x equals negative 3 over 2 plus 3i root 3 over 2. That a little bit better. And negative 3 over 2 minus 3i root 3 over 2. Okay, so that's our 1 real, 2 complex. That's a total of 3 solutions there. Just always remember, you can see it here, we get conjugate pairs like this. So as long as you have 1 imaginary one, you always have 2, because that's how complex roots will always pop up. All right, so now we're going to use synthetic division or synthetic substitution to find our zeros here. So we find all of our zeros for this one. The first thing I want to do is I want to graph the function in a graphing calculator. Okay, so we're going to do that first. After that, check the calculator for any rational real zeros. Okay, once we find rational real zeros, we're going to take that and then plug those into the synthetic division. which will depress the polynomial. We keep going until we can solve a polynomial that is just a quadratic. And then we can use our quadratic formula. So let me pull up the graphing calculator. We have x to the third. Let's see, it should be right here. Nope. There we go. So where y equals, let's clear that out. That was x raised to the third power. Back here, minus x squared plus 2x minus 4. Whoops. Okay, x to the third power minus x squared plus 2x, I forgot what it was, minus x squared plus 2x plus 4. Okay. Okay, accidentally did that, delete, plus 2x plus 4. Okay, so we go to our graph right there. And we can kind of see pretty much where it is. We only have one real zero. So that's what we're looking for. So I'm going to go ahead and do my calculate option. So let's clear that part out. So second calc, go to number 2 for my 0. Left bound is down here. As long as I'm on the left side, hit enter. Go to the right side of it, hit enter. And it looks like I got it at -1. Okay, that's what it says right there. All right. So we know that -1 is a factor. So I found my real rational, x equals a -1 for that, which means I'm going to start with doing this and do my synthetic division now. So I've got 1, -1, 2, and 4. And I'm going to run through. So I got bring the 1 down, multiply -1 times 1 is a -1. Put those together, I get -2. Multiply -1 times a -2 is a +2. Put those together, I get 4. And -1 times 4 is a -4. And I get 0 as a remainder, which is what I expected. Okay. So again, that's get the remainder of 0 because that was my rational root. So this is x squared minus 2x plus 4. So the goal here is to solve this. Now you saw it from the graph, we only crossed one time. So that means I know I'm going to have to go to my quadratic formula right now. So x equals -b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Okay, so x equals +2 plus or minus, those will be a 4. -4 and a +1 and +4 is going to come out to a -16 all over 2. So that'll be 2 plus or minus the square root of -12 over 2. So just like before, I'm going to break down -12. So it's a -1 times 12. 4 times 3, so that has a perfect square root of 4, but not the 3. So this will turn into 2 plus or minus. I got the square root of 4 is going to give me 2. This -1 will give me an I, and then it has square root of 3. That's all over 2. Since 2, 2, and 2 are all divisible by 2, I can simplify that further and make it 1 plus or minus I root 3. So I have one real solution. Okay, I got one real is that x equals -1. And my 2 complex is going to be 1 plus or minus I root 3. Okay, so we're going to do the same exact thing here. Find all the zeros of this polynomial. Okay, f of x equals x to the 5th plus 2x to the 3rd plus x. So back to my graphing calculator. Okay. All right, we'll clear that out. So x to the 5th. Forgot what it was already. That's not good. Plus 2x to the 3rd plus x. Okay. Plus 2x to the 3rd plus, well, I did that wrong. All right, try one more time. X to the 5th, arrow over, plus 2x to the 3rd plus, I think it was just an x. Let me just double check. Yep, we're good. Okay, so we'll graph that. See, we only have, once again, we only have one real zero. So if I do that real fast to confirm it, but it looks like it's happening at 0, which the screen kind of does tell me, but just to be on the safe side. So second calc, put number 2. I didn't want that. Okay, let me pause it real quick. All right, we'll try that then. left bound, you can see the cursor is just a little bit past that, so I hit enter, arrow to the right, hit enter, and I do get a 0 at 0. So I come back here. I have one real solution at 0. Okay, so there's my real one. So that means, honestly, I could just do this. So I can actually do this a little bit differently. If I want to find all the zeros, then I'm going to do this where x is going to factor out of everything. I'm going to have x to the 4th plus 2x squared plus 1. And I didn't have to graph that at all. So that's actually a good thing to bring up right now. Always double check if you have like a GCF, which we do have here. So because of this right here, this is how I get to x equals 0. Whoops, whatever. Okay, that means I need to now solve this. X to the 4th plus 2x squared plus 1 equal to 0. Okay, so in this case, so we got, yeah, that's going to be an interesting one. Give me 1 second here. Okay, sorry about that. Just had to double check one thing. All right, so now to help solve this, I'm going to go ahead and kind of transform it using that u substitution as before. If I call u x squared, that means that's the same as u squared plus 2u plus 1 equals 0. Okay, so this is factorable. This goes, what multiplies to 1 but adds a 2, u plus 1 and u plus 1. So because of that, all I care about here is that if u plus 1 times u plus 1 equals 0, then that means u plus 1 equals 0. Well, remember, I have x squared as u, so that means I could say x squared plus 1 equals 0. So if I solve that, I'm going to subtract 1 over, so x squared equals a negative 1, and then I square root both sides. Well, that means I get x is equal to a plus or minus I. So there's my complex ones then. So I got x equals 0 is my real solution, x equals plus or minus I for my two complex solutions. Okay. All right, and that is it for day 1. So continue on with more of these ideas later. Bottom line is you can use in this case, I was able to use just factoring a GCF, but the big key I want you to take from this is using synthetic division to kind of break down a polynomial into like smaller parts, and then using that part and solving that to get our complex solutions in the end. Okay, that's it for everybody. Take care.